Hello, everybody. Welcome to Nacel's talk on eventual consistency and interoperability in the headless commerce. I just wanted to note initially that we will be recording this call. My name is Devin Saxon. I am the Senior Sales Engineer here at Nacel.
And I'm Brian Anderson. I'm the founder and CEO here at Nacel.
Cool. And we have just like I said, a talk around eventual consistency and interoperability today. And we're going to give you a little bit of guidance around headless architecture as well. Brian, I'll let you take it away from here.
Yeah, so I think the best way to start our conversation around headless commerce is actually to do a review around the difference between monolithic stacks and microservice architecture. So our first slide is going to talk about the pros and cons of monolithic architecture. Devin, if you could flip to that one. Yeah, so I know monolithic architecture kind of gets a bad rap these days in favor of microservice architecture, but there's a number of pros that you really have to consider with a monolithic stack. First is apparent, and that's it's easy to get started. I remember years ago when I made my first Ruby on Rails application, and I went in and I built some scaffolding, and all of a sudden within a short period of time I was actually able to build a whole CRUD app and make changes to the database quite quickly. So it's easy to get started, and it doesn't take as much upfront architecture work as it might if you were doing a microservice approach. It's also proven to scale. I think there are a number of large open source projects and businesses that are publicly traded that operate at significant scale that they represent monolithic architecture at the end of the day. That doesn't mean it's the most affordable, I think, or the most cash efficient. I do think there's quite a difference between vertical and horizontal scaling, but it does scale nonetheless, and it's been proven to. There's also a number of nice things about monolithic architecture when you think about data consistency, specifically the idea that there are asset guarantees. And what this means is when you save an object in a monolithic architecture, and you get a response back from the system that, hey, this object has been saved and committed to storage. That's generally true across the entire monolithic service. You never have to worry about data discrepancies. So these are some high level. I think there are other pros as well, but when we think about monolithic architecture, these are some of the pros that we're pretty fond of. The cons is that it's very difficult to push changes, and if you look at the acceleration of engineers over time as a monolithic project grows, there tends to be this inverse correlation where as the project gets older, the velocity of engineers tend to reduce, and there's a number of reasons for that. But one issue is it's very hard to think about how do I push a change without asking other squads or other enablement teams to make alterations for me. And ideally, I can just make those changes without other teams. But when I'm dependent on other teams, then it does slow my overall velocity down. It's also not really built for bespoke services. So your monolithic architecture, it doesn't really want you to pull in some sort of third-party service, and at least not without a lot of work and a lot of effort from your engineering team. And the third is it's expensive to scale. So while it's proven to scale, the fact that you have to scale, sort of vertically, if you will, instead of horizontally, I don't think we have to get into the details of those two methods of scaling, but it's generally proven that horizontal scaling is a little more cash efficient to scale than vertical scaling. So some good pros and some good cons of the monolithic architecture. But let's contrast that now with microservice architecture. One of the tremendous pros of the microservice architecture is the idea that there's actual individual database sets for each microservice that's involved. And what that means is you have a true decoupling between the different services in your stack. If you contrast that with a monolithic stack, it's very difficult to make changes. Well, the theory is if you're a microservice, you're leveraging microservice architecture, I can make a change to an object without having to go to, say, the database team to actually do a database migration. And I know that that's true because I actually own the underlying data stack. Because it's decoupled, it's also quite easy to change services in and out and maybe use bespoke third-party services that weren't homegrown, but it could benefit you nonetheless. In the world of e-commerce, we often see our merchants pair in things like a third-party CMS or third-party PIM, and making those changes quickly and efficiently without having to do an enormous rebuild is a big benefit to the microservice architecture. There are some cons to microservice architecture. The first is interoperability concerns. If you're pulling in data from a third-party bespoke service, for example, you might have to update the API interface or the contract between you and that third-party service. You might also have to maintain that over time. Maybe they make an update to their schema or they roll out a new version, and now you're sort of forever in maintenance mode dealing with that. And so interoperability concerns are a real issue with a more bespoke or even a microservice architecture. The other big issue, and we talk about it quite regularly at Nacelle, is this concept of eventual consistency. If you contrast the microservice architecture to the monolithic architecture, you realize that, oh my gosh, this is great. We have our own databases for every microservice. But now if I save a change or I update the database or I update a record in the database, it doesn't mean that change automatically propagates to every other system in the stack. And that's quite the contrast from the ACID-based sort of guarantees that's offered in monolithic services. So if you hit save, it might save for that one service, but that doesn't mean that data is going to be consistent across all the other microservices in your stack. And so what that leads to is this idea that APIs aren't really enough. You can't communicate through your microservices just simply through APIs. The world has kind of pushed us toward this idea of, sort of an event-based stream. I think a pub sub model is also a good idea to consider when you're building out your microservice architecture. But generally speaking, APIs are not enough. You want a way to kind of, use some sort of pub sub model and maybe even replay the messages that flow through that model. Okay, so now that we've done this review, what we found when we were doing headless commerce builds is that there's a lot of analogies you can draw between going from a monolithic stack to a microservice architecture. And because you are decoupling the front end from the back end in a headless build, you really have to consider the fact that you are actually adopting more of a microservice architecture than you were traditionally with a monolithic stack. So with that, I'll pass the baton off to Devin, and he'll start to talk about some ways to go headless in commerce.
Yeah, thanks, Brian. So now that we've gone over those pros and cons between the monolithic and microservice systems, let's take a look at three common sorts of implementations that we see around a headless architecture. And in order to really show the value of each of these builds, I'm going to be ranking these approaches based off of 5 different categories. Flexibility, which is just talking about how easy is it to scale when you go to this type of headless architecture. Data consistency, is everything my shopper's seeing on that front end exactly aligned with all the information that's available within those back-end systems? Like, are all of those aligned? Maintainability, just another way of saying developer maintenance. And then finally, ease of use. How quickly and easy is it to build this headless architecture? And cost being the last thing, both actual price-wise and developer effort-wise. So hoping that these next few slides will be like a guide for you as you're making a consideration towards leaping into the world of headless. So let's go ahead and walk through one of the more common ones that we see, which is known as the daisy chain approach. So from the initial looks of it, it looks pretty streamlined. We live in an e-commerce world, so a lot of these slides will be focused on e-commerce builds. But say that you have a product inventory manager or an e-commerce platform, and that's going to be pointed directly to a headless content management system, since you're now removing that content management system away from that monolithic architecture that you may have been living in before. And that content system is going to be paired directly towards that PWA, that progressive web app front end that your shopper is going to be interacting with within that web store. So now here it looks pretty clean, and we see that content management system is acting as this pairing of product and content for the front end build. But if you look a little more closely, you'll see that there's kind of multiple points of eventual consistency within this build, because not only is this content management system now acting as this middle layer between your backend and front end systems, when ideally a content management system should also be a backend system. You really need that content management, that CMS, to be tightly coupled with whatever PIM e-commerce platform that you have, because they need to be aligned in order to ensure that customer is seeing what they should be seeing. On the flip side, you really need that content management system to be tightly aligned with your PWA to enable those non-technical members of your team to be able to stand up landing pages or make changes to your home pages in a real efficient manner. So if you think about that, that's two different points of bottlenecks or stress, I should say, like throttling that is within this flow of data to your front end. So now if you make an update within your PIM, or even if you make an update within your content management system, you really are going to be kind of playing catch up and hoping that both of those infrastructures are on time with each other and in sync. So unfortunately, what a lot of customers do in order to alleviate that risk of a product inventory not being shown within the PWA, like say that if it's out of stock or that price, you made a price change that is not really reflecting, they'll move to something that's more like this. And they have that PIM that's now also talking directly to the PWA to act as this like extra added net of security to ensure that that customer on that front end is seeing exactly what they should be seeing. So a little complicated, a little convoluted. So let's just go over and see how that rating system sort of looks. Flexibility, a 3 out of 5. I'd say that, I mean, at the end of the day, you're going to be staying on your traditional like e-commerce monolithic platform or whatever that product inventory management system is, and just adding a headless CMS solution. So flexibility, the at scale portion looks pretty clean as opposed to excluding that PIM to PWA tracking that you need to do. But as we've seen all those bottlenecks that are within this build, data consistency is a 0 out of 5. It's a huge issue. Just the fact that a developer now needs to add that extra security of that e-commerce platform talking to the front end just really shows that data risk is huge. And that kind of links all the way down to the rest of the pieces. Maintainability and ease of use now are more so leaned on the developer to ensure that everything is how it should be. And then finally, the cost. The upfront cost may not be a lot since there's a lot of affordable headless content management systems. But at the end of the day, if you take a look at the ease of use, maintainability, and the data consistency issues, that's a lot of responsibility that's going to be left up to the developer at the end of the day. So let's go ahead and go to the second approach, which doesn't really have a Clover as a name, but just say it's a bespoke services. You have all of these different backend dependencies from your content management to your product inventory manager, order management, CRM, price books, etc. And all of them are independently communicating to your front end. But as you can see with all these arrows, there's already a lot of complexity issues when it comes to now what the front end developer will be responsible for and what they're burdened with when it comes to being able to build that web storefront. They need to know the APIs and the rate limits with the CMS, with all these different systems and how the infrastructure works with each of those systems and the schema that's needed in order to be able to reference all of those pieces for your front end. So along with just having that breadth of knowledge, you also have this spaghetti string of code that everything is all mapped all over the place. And one thing that's not actually shown on the slide is that all these backend systems will also need to communicate with each other for pairing reasons to ensure that it grabs data that it needs in order, again, for that front end build. So not only do we see an issue with spaghetti string code, but we see an issue with all of these different bottlenecks and points of eventual consistency or like throttling. So now, which is actually this type of headless build was an impetus to how Nacelle was founded and started. But if a person within your team wanted to make an update to a product, a price, or if they wanted to add a new sale like image on one of their landing pages or home pages within their CMS, that wasn't reflected on the front end hours or even a day later. So this, even though that this type of build gives you that flexibility of a headless architecture, the maintenance cost around it is pretty great. And I feel like I'm getting a little ahead of myself. So let's go ahead and jump to the score to see what it is. Flexibility, like I just said, 4 out of 5. You really are just adding as many systems as you need within the back end and just pointing everything towards the front end. But you're really sacrificing is data consistency, maintainability, and ease of use, because all of that work in order to gather all the context that you need for that storefront is now directly responsible to that front end developer, which at the end of the day, they shouldn't be worried about. They should be just worried about focusing on that front end build, not worried about what each of these back end systems need to do and when they're available and how can they communicate to each other, just to make my job as a front end developer a little easier. So now if we look at cost, again, not really at that front end cost that you'll see, but the maintenance cost is just super drastic. So just a thing to note. Which now brings us to our solution, a solution that we recommend, which is building around an abstraction layer. using this event-driven sort of method. And the first thing that I think of when I look at the side is interoperability. I really have been struggling with this word all day. But the layer of abstraction in this case is doing the work for you. You don't have to deal with the burden of making a back-end abstraction layer in the front end of the code base. And specifically for Nacelle, our APIs are performant to be able to manage that whole pre-rendering load that's essential in that static site build for your Jamstack web store or that PWA. Since we, as you see, all the back-end components are pointed towards the abstraction layer, indexing that information, making it readily available, and it'll have individual like webhooks or sequences in order to make sure that whenever somebody is updating anything within these systems, it'll automatically get indexed into the layer, making it readily available for that front end build. But now on that other side, that abstraction layer has this infrastructure to be able to handle all of those API calls that are necessary in order to gather entire context of your front end system, or back end system, I should say. So let's see the scores around this. 5 out of 5 when it comes to flexibility. You really are taking away the stress again from your front end developer, really needing to map everything to your back end or having your back end need to be a certain schema for your front end individually. This abstraction layer removes all of that tech debt altogether. No need for spaghetti string type of code, which now makes everything in terms of data consistency super consistent. Because if you have this place where all the information that's needed for that web store build is available in index within that layer, you no longer have to have your PWA making these calls directly to those backend systems, which, as we've seen in the previous slides, is where you really find yourself into a lot of trouble. Maintainability also gets clean, same kind of for that similar reasons of that flexibility, the single APIs, removing all that spaghetti string of code, which also doubles down within the ease of use. And the cost portion, there's more of an upfront cost, definitely for sure, by going and like purchasing an abstraction layer for your headless architecture. But if you think about the maintenance after that and adding more systems within your headless build, it's totally worth the upfront cost at the end of the day. No bias. So with that being said, that was our review and walkthrough of kind of our recommendations of the 3 different headless architecture builds that we see. So we hope that is good information for you to keep and go forward with. So thank you, and we have time for questions or any comments.